All right, here is our example of partial fractions with a repeated factor. So again, anytime you've got that repeated factor in your fraction, what we're going to have to do is split up that factor as a single factor and as a repeated factor. So we're not quite sure if we had just that x plus 5 squared, or we also had just a plain old x plus 5, because we totally could have. And that would give us still that same least common denominator. So our answer here for our setup is B. And it is definitely possible that this term is not going to be needed, that first one. And if that is the case, we will get A being 0. But it is very possible we do need that term. And that's how it helped us get our x plus 6. And so anytime we've got this repeated factor, you're going to have it there a single time and then that squared time as well. And if it happened to be a third, an x plus 5 to the third, we'd have it there as a single term, as the squared term, and as the third term, or to the third power. So now let's find our coefficients. So just like before, we are going to take and multiply each of our terms by our least common denominator, which is still just going to be x plus 5 squared times x plus 2 squared, x plus 2, and then everything should cancel out for us on our denominators, and it does. So now we have x plus 6 is equal to a times x plus 5 times x plus 2, b times x plus 2, and then c times x plus 5 squared. Now, this is one where we're going to have a little bit of a harder time using that strategic substitution, but it's not going to be too bad. We still can use it. So let's see what happens here. So again, we're going to substitute in those numbers that make our denominator 0. So in the case of this problem, x equals -5 and x equals -2. So let's go over here for x is equal to -5. And remember, you're plugging it into both sides of your equation. And when we multiply a times x plus 5, that's going to give us 0. And then we're going to have -3 there. And let's see, b is going to be times -3. And c is going to be multiplied by 0. So it looks like this is going to give us what b is. All right, so we're going to get that b is equal to, oh, that's not negative, that's positive. So b is going to be equal to -1/3. And then let's plug in x being -2. So that's going to give us -2 plus 6. We're still going to get a times 0. This time we're going to get b times 0, but we're going to get c times 3 squared. So that's going to give us 4 times, or equal to c times 9. So we get 4/9 for c. And then we can use one of our equations that we get from our system of equations. Let me copy this statement right here. So let's copy this and paste it right here. So from this, we get x plus 6 is equal to, let's do some quick foiling. This is going to give us x squared plus 7x plus not 14 plus 10. So we get ax squared plus 7ax plus 10a from multiplying through by a. Then this middle term, that's not too bad. We get bx plus 2b. And then our last term here, x plus 5 squared is x squared plus 10x plus 25. So multiplying through by c, we'll get cx squared plus 10cx plus 25c. So we can use, let's see here, we can use that, and we have 0x squared here. We can use this fact, the x squared, that 0 is equal to a plus c, because we know c is 4/9, and a is equal to the opposite of c, so a is going to be -4/9. So we've got our a, our b, and our c. All right, so, oh shoot, I wrote all over that. It's all right. So let's see. So our original integral that we wanted to take was the integral of x plus 6. And then we had our three factors, I guess, plus 2 dx. And then we split it up to be a over x plus 5 plus b over x plus 5 squared, and then c over x plus 2. And then we found that a is -4/9. So what we can do with this is write this out as a coefficient out in front of that fraction, so you don't have to put a fraction on top of your fraction. And we can do the same with b. We can write that as -1/3 times 1 over x plus 5 squared. And then same with our 4/9 times 1 over x plus 2. So now our first term here, our first integral, that's just going to be one of our natural logs. So we're going to get -4/9 times the natural log of x plus 5. Our last one here, that is going to give us +4/9 natural log of x plus 2. We'll have our plus c on the end, let's not forget that. And then this middle one, we can rewrite that as -3 times x plus 5 to the -2 power, and we can use the power rule. So we'll get plus -1/3 times -1, and then we'll get x plus 5 to the -1 power. So then just, making this look nice, we get -4/9 natural log of the absolute value of x plus 5 plus 1/3 times 1 over x plus 5. And you could put those in together as one fraction if you want, but I think I'm going to leave it like that.